Hello everyone. Before starting our today's section, let us see what we have seen in Introduction to CNC Part 1 and Part 2. Now, in Part 1 we have seen the need of the CNC machine, its advantages, also its description, its working, its history, and also we have seen the NC machine, the basic components of the NC machines, and the different components of the CNC machines, CNC's applications, also the types of CNC machines, where we have seen the CNC turning, CNC milling, CNC coordinate measuring machine, CNC plasma cutting, CNC press, CNC rapid prototyping, and also we have seen the CNC machines axis of motion. Okay, that is three transverse directions and rotary directions, and also we have seen the CNC motion control, that is point to point motion, straight cut motion, and contouring motion. Okay, this we have seen in part 1. Okay, and in part 2 we have seen the advantages of NC system, disadvantages of NC system, CNC programming basics, CNC programming, also the important things while doing the CNC programming, and also we have seen the key letters, the meaning of the various key letters while uses during programming. Okay, say for example, O for program number, T for tool designation, S for spindle speed designation, M for miscellaneous function. Along with that we have seen the G codes. We have seen the different G codes, Z00, that is rapid transfer, Z01, Z02. So we have seen the various G codes, and we have seen the M codes, that is M00 program start, M01, M02, M10, M11, M30. And after that we have seen the rules for programming. In that we have seen one block. Okay, and that is first of all the line from the line becomes from different alphabetics and numbers. Okay, from this becomes a line, and line is nothing but a block, and by combining all these blocks it becomes a program. Okay, so if you observe finally the block contains alphabeticals and numbers, where the block starts with alphabeticals and ends with a number. Okay, till now we have seen this much in part 2. Now today we will see the programming of the for turning. Okay, as in screen you can see the raw material is there, cylindrical part having diameter 25 and the length is 70 mm, and we need the finished part here, which is given in bottom. Here the APT is nothing but the automatically programmed tool is there. Now in this I have already made the program. Let us see the one by one the meaning of each block. Let us go. So first, that is N0013, that is O0013. O is nothing but for a program number, so O0013 is program identification number. Okay, then the next block is N0005 G53. Now here if you observe, the block is starting with N0005, not with N0001. Why? So let me tell you the brief information regarding this encode once again. So encode is, as we know, that is it is a sequence number which is used to identify the block within NC programs, and it provides a means by which NC commands may be rapidly located. It is a program line number. Okay, now it is a good practice to increase each block number by 5 to 10. I am going to repeat once again that it is a good practice to increase each block number by 5 to 10. Why? To allow additional blocks to be inserted if future changes are required. Okay, I am once again repeat that it is a good practice to increase each block number by 5 to 10 to allow the additional blocks to be inserted in between them. Why? If future changes are required. Okay, so due to that, here N0005 is there. Okay, and G53 is for to cancel if any previous working 0 point is there. Okay, that means if before this job, if any other job is having different shape, job is used on that machine and they set some 0 point, so to cancel that 0 point, this G53 command uses or code uses. Okay, now next block is N0010 T0303. That means in this we are going to select a tool number 303. Okay, so here selecting a tool number 303, then the next block, that is N0020 G57 is there. G57 is nothing but to set the working 0 point. Okay, G57 is nothing but to set the working 0 point, and G00 is for rapid movement. That means in this rapid movement there is no any cutting is there. Okay, so we are going to set the working 0 point is that X26, okay, as diameter 13 from 0, and Z0 Z location that. But here let us finish this block. S500, that is spindle speed is 500 rpm. M04, that means rotate the spindle counterclockwise. Okay, now in this machine, as I already told you in previous my lecture, that the spindle's axis, okay, it is always a Z axis. So this is Z positive, this is Z negative. Okay, and I also told you that the horizontal axis, okay, the perpendicular axis, that is a x axis is there, sorry, x axis is there. That means this direction is x, this is Z positive, this is x, and the remaining is y, which is not over here. Okay, so this is Z, just the spindle axis, that is a Z axis, Z positive, this is x axis, x positive. Okay, now we set the working 0 point. Okay, now let us see the next block. Okay, that is N0030. As we set the tool, now we are going to do the facing operation. Okay, so Z01 X0 X minus 0.20 F100. Okay, as here you can see 2570, we set the tool over here. Now we are going to do the facing operation. Okay, so N0030 Z01 X minus 0.20 F100. Now Z01 is for a linear interpolation. That means we are going to perform a cutting operation. Okay, linear interpolation. And X minus 0.20, that means move only in X direction. Okay, until you pass the center by 0.1 mm, that is a facing. Okay, now F100, that means set a feed rate to 100 mm per minute is there. Okay, then here comes the next block, that is N0040 Z00 Z2.0. Okay, in previous block we've performed a facing operation, cutting operation we have performed. Okay, now we have to bring back the tool. Okay, for that z00 is there. Okay, z00 is for, as we have seen, the rapid transverse movement. Okay, the tool move rapidly away from the workpiece and there is a no any cutting is there. And z 2.0, that means the movement is 2 mm away from the face. Okay, now after that the next block, that is n005 x50 z50, is nothing the meaning of is that go to a safe location away from the workpiece, that is x is equal to 50, z equal to 50, to change the tool. Okay, now the next, that is n0060 t0404. Okay, so first we perform the facing operation. Now we are going to change the tool. So this is for nothing, to change the tool. Previously we have used the tool 303. Now we are going to use a tool 404. The meaning of this block is select tool number 404. Okay, now next, that is a next block, that is n0070 g57. G57 is nothing but for a work coordinates offset. Okay, and G00 is a rapid movement, that means there is a no any cutting is there. Okay, and the tool's location is x22.50. X location adds a diameter 11.25 from a 0, but x is equal to 22.50, and z 2.0 z location, and spindle speed is 500 rpm. Okay, now we are going to perform a turning operation. Okay, now after this the next block is there, that is n0080. it is z01. Z01 is nothing but for a linear interpolation, that means we are going to perform a cutting operation. And z minus 30.0, that means the tool should move only in z direction, that means we are going to perform a turning operation over here. Okay, and during this the f100 is nothing but set feed rate to 100 mm per minute. Okay, now we'll come to the next block, n0090. Here g00 is there, as we have seen. First it performed a facing operation, then came back rapidly, then it performed the turning operation. Now we are going to now call the come back. Now the tool will come back. Okay, that is z00, that is there is no any cutting during this operation. Okay, after turning the tool will move rapidly from the workpiece and there is no any cutting, and it move to the location, that is x23 and z 2.0. Okay, now after that the g84, that is the next is, that is the n0100, that is g84 is there. G84 is nothing but for the turning cycle, for machining the step. Okay, now let us see the meaning of each in this block. Okay, g84 is for turning cycle for machining the step, and x is nothing but x17.5, that is the final diameter which is required, over here. Okay, now x 17.5 and z is minus 20. Okay, z, that is the length of step is 20 mm. Okay, diameter is 17.5 and length is 20 mm. and D0 is nothing but 200 finish allowances. In X direction it is 0.2 mm, and D2 is equal to 200, that is finish allowance in Z direction 0.2 mm, and D3 is nothing but depth of cut in each pass, that is 0.65 mm. Okay, and after this the next block, that is N0110 Z00 Z2.0. okay, that means after performing the cutting operation the tool should come fastly. That means after performing the cutting operation you are supposed to enter Z00, so your time will save. So here you can see in N0110 Z00 is there. That means the tool should move rapidly from the workpiece and there is no any cutting. So, and it comes rapidly, and further there is Z2.0, that means the movement is 2 mm away from the face, and last that is N0120 X50 and Z50. Okay, that means the tool should move to the tool changing location. Okay, and last that is N0130 M30. M30 is for program end. Okay, so here you can see. Okay, I am going to tell you once again. Okay, so I will just call the number. Okay, so first that is 00013 for program identification, and next N0005 G53 is for any to cancel any previous working 0 point. Okay, and after that we are going to select the tool, that is we have selected tool 303 tool number, then we set the working 0 point. Okay, and G00 for rapid tool movement we set the working 0 point, that is X26Z0. Okay, also we have set the spindle rotation which is in counterclockwise direction having the speed 500 mm. Okay, and then in third block, okay, what we did, we perform the facing operation. Okay, in this block we have used the G01 for linear interpolation, that is for cutting, and by giving this value, that is x minus 0.20, okay, by giving this input we are going to perform a facing operation. Okay, having the feed rate is 100 mm per minute. Okay, and after facing, after this program, if you observe in N004 G00E, we inserted G00, that means the tool should move rapidly. Okay, means after performing the operation the tool should move rapidly to this position, to Z2.0. Okay, this is N0030. Now if you see the N004, that we have seen the tool moves rapidly to Z2.0, next is that is N0050. That means after moving this tool it should go to a safe location, as first operation is performed, facing is done. Now for next operation the tool should be changed. Okay, so for that it should go to a safe location, so X50 Z50, this is a safe location to change the tool, after that we change the tool, then we have selected this N007 G57, it is for work coordinate system. Again we move the rapidly tool at this position X25 Z2.0, spindle speed 500 rpm. Okay, now after that we are going to start the turning operation. Okay, so initially what we did, we set the we cancelled previous working point work 0 point, then we set the 0 point, then we performed the facing operation. We perform the facing operation again. After that, tool moved away from the workpiece, then it goes to the safe location, then the tool is changed. Now we are going to perform, but and then it come to close to the workpiece, and after that we are going to do the turning operation. Okay, in this again G01 is linear interpolation cutting Z, that means the tool should move only in Z direction to perform a external turning at a feed rate of 100 mm per minute. Okay, now after again turning, the tool should move rapidly. Okay, the tool is moved rapidly. Okay, here if you see Z30 here, the turning is performed over here, and the next in N0090 the tool is more rapidly away from the workpiece to this location at this speed. Okay, so after this, okay, first we perform the facing operation, then turning. Now the step turning is there. Okay, so for step turning we enter the code G84. Okay, G84 for turning cycle for machining the step, and we enter the value x is equal to 17.5. it is our final diameter, and Z is having the value 20 mm. Okay, the steps length is 20 mm, steps diameter is 17.5 mm. Okay, and we have given some finish allowances in xyz direction. D0 in x direction allowance is 0.2 mm. In z direction we have given only x and z is there, there is no any y. So in x direction we have given the 0.2 mm allowance. In z direction we have given the 0.2 mm allowance, and in depth of cut, the depth of cut of each pass we have kept the finish allowance 0.65 mm. Okay, that is the 0.65 is a depth of cut in each pass. Okay, so during each pass the tool moves 0.65 mm. Okay, the depth is 0.65 mm. Okay, and after that, as we came over here, our required part is prepared, and after that the tool moves away from the workpiece. Okay, G0 Z2.0, and after that again it goes to the safe tool changing location. Okay, as we have already here seen, first of all after performing a facing operation it goes to the tool changing location, and after performing turning and step turning, it again goes to the tool changing location over here. Okay, and after all these we are supposed to end the program, and to end the program M30 is there. Okay, now here we are going to see the key letters which used over here. Here if you see O is used for a program number, that is used for a program identification number, and N is for a sequence number which used for a line identification, and G is for a preparatory function. Okay, and XYZ it is axis designation, and F is for feed rate designation, S is for spindle speed designation, T is for tool designation, okay, and M is for miscellaneous function. Okay, now I am once again going to repeat this. Why N005 is here, why not N0001 is there? Okay, so I'm once again going to repeat in detail, that is for encode. Okay, encode, as we know, it is a sequence number and it is used to identify the each block within a program, and it provides a means by which commands may be rapidly located. It is a program line number. Okay, and it is a good practice to increase each block number by 5 to 10. Okay, remember remember this thing, that is it should be a good practice to increase each block number by 5 to 10. Why? To allow, okay, to allow additional blocks to be inserted if future changes are required. So it is a good practice to increase each block number by 5 to 10 to allow additional blocks to be inserted if future changes are required. Okay, suppose in between these, if we have to perform in between one operation, okay, so for that we can insert a block in between these. Say for example, if we want to uh, change the tool in between these, and this we want to change before the step turning. Okay, that means before N0100. So here if you see here, the gap of 10 block is there, or here 9 block is there. Okay, so here I can insert, sorry, here N00, as I can insert N0091, that change the tool, that is to T0353. okay, or I can enter N0092, N0093, N0094, N0095. so such blocks can be inserted. Okay, so for that the this gap is kept 5 to 10. Okay, and last time I am going to repeat it, that okay, so it is good practice to increment each block. Okay, it is good practice to increment each block number by 5 to 10. It is good practice to increment each block number by 5 to 10 to allow additional blocks to be inserted if feature changes are required. Okay, so don't go directly for N0001, N0002, N0003, N0004, N0005. So make a practice to keep a increment of 5, or to keep a gap of 5. That means 5, 10, 20, 30, 40, 50, 60, 70. Okay, so make a good practice to increment of each block number by 5. Okay, so if we want to change something, or if any changes occurs in the design, okay, in finish the product, you can insert that block in between these. Hence the increment of 5 to 10 should be maintained over here. Okay, you can see over here 5, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, gap of 5 to 10 is kept in between these. Okay, so here we are going to stop. In next lecture we will see the DNC subroutine, canned cycle, automatic tool changer, automatic pallet changer. Okay, thank you.